Today's Daily Dose of Math is examples 3 and 4 of graphing a step function using the parameters. Parameter A is 2, parameter B is -0.5, parameter H is 0.5, and parameter K is 1.5. The thing that's a little different about this example is that I'm choosing to make H and K be numbers that are not whole numbers, so that we can see how that plays out when we get the curve onto the graph. First thing that we do is pull out our H and K. And we have 0.5, 1.5. I can put a point on my graph right away. 0.5, 1.5 is going to be a closed circle right here. Next, the sign of B. The absolute value of B is equal to 1 over the length of the steps. The absolute value of -1/2 is 1/2, so the length of steps is 2. The sign of B is negative. When B is negative, it means that the steps are closed on the right. So I can draw my first step. This is closed on the right, so the step is going to move from the left of this point. And the step has to be 2 units in length. It started at x equals 0.5, so it's going to go over to the left to x equals -1.5, where I need an open circle. I've drawn my first step. Next thing to do is look at A. The absolute value of A is the height of the steps. In this case, the absolute value of A is the absolute value of 2, which is +2. My steps are 2 units in height. So therefore I'm going to need a step 2 units above this, a step 2 units below it, etc. I need to also find AB. AB, the product of parameters A and B, in this case is 2 times -1/2, which is -1. That is the slope of the imaginary line that connects all of the closed circles on my steps. The slope is negative, so that means that that line would have a negative slope, which means that we are going downstairs. We have enough information now to start drawing our other steps. We need a step that is 2 units above this one, and if it's going downstairs, it means I need a closed circle 2 units above here. This is at 1.5, so that will be at 3.5. And then I draw my step to the left of that, 2 units in length, which goes from -1.5 to -3.5. Brings us right about to the end of the graph as I drew it. I'll draw the closed circle that will be 2 units above that. 2 units above 3.5 is 5.5. That just barely fits on this graph. So I'll put the closed circle. I'll show the beginning of the step leading off of that. And that's enough over here. Now we need a step below this one. Again, it's 2 units below. This is at 1.5, so that'll be at -0.5. I need an open circle here. And then I'm going to draw 2 units to the right of that, which will be to x equals 2.5, and put a closed circle. 2 units below that is going to be -2.5. I need an open circle here. And a step going 2 units to the right of that, which brings us to the end of our graph. And I don't have room to show any more. So I have finished graphing this step function. Someone who looks at this graph would be able to figure out the pattern, answer questions about the situation, even if they don't know the equation, and in fact, that person would be able to take steps to derive the equation of this step function, because all the clues they need as to the parameters are in the graph. I'm going to quickly make another example, and then we'll continue. Okay, I'm ready. So here we have a different function. A is 2, B is 2, H is 1, K is 4. Right away we pull out our HK. And we put a dot at 1, 4, which with the scaling I've chosen puts a closed circle right here. Our b is 2. The absolute value of b equals 1 over the length. The absolute value of 2 equals 2. How is 2 equal to 1 over something? We have to do an inverse. 2 is equal to 1 over a half, because 1 divided by a half is 2. So therefore my length is 1/2. I'm going to have quite a small step. The sign of b is positive, and that means that my steps will be closed on the left. So therefore I'm drawing this step to the right of this point. The steps are half a unit in length, so I'm only going up to x equals 1.5. And I'm putting an open circle. Now I need to look at my a. The absolute value of a is the absolute value of 2 in this case, which is positive 2. That means that my height is 2 units. I need another step that is 2 units above this one, and another step 2 units below, etc. But I need to know the slope of the imaginary line that connects all of the closed circles. For that I use AB. AB equals the slope, which in this case is 2 times 2, which is 4. It is positive. That's a positive slope. That means that these stairs are going upstairs. And that's the last bit of information I need so that I can draw the rest of my steps. Upstairs, 2 units in height above this one is right here. And I draw a line that is half a unit in length. And put the open circle. Upstairs from that is going off of my graph, so I won't show the next step. Downstairs from here, we need an open circle right here, and a line going to half a unit to the left of that, and then a closed circle. And then 2 units below that, we need an open circle, a line going half a unit to closed circle. This is landing right on the x-axis, so it's a little harder to see. So as you can see, it's a little tricky to draw because the steps are so short on an upright chalkboard, but it's a lot easier to draw on graph paper. And this is the last of my 4 extra examples about how to graph a step function using the parameters. The special thing that happened here was that b was a whole number, which means that I'd had to slow down and be a little more careful when I was calculating the length of the step. That is today's Daily Dose of Math. Please like, subscribe, and share.